Okay, well, what do you get? Yes, it does affect performance. That's one negative. You have to go through the network interface. It's about the same speed whether you're in this. It's the same speed even if you're invoking software inside your computer because you're going through the operating system and the network interface and all the way back to software inside. But this makes it decomposable. So that's one of the negatives. The other negative is, when we talk about dependability, it's a lot easier when something breaks if the whole thing, it's either working or not working. Those are the two states. The problem with these independent services that can be running on different servers is some of the components are running and some aren't. And that partial failure is a lot trickier to figure out what to do and to even recognize it because some of it's working. So those are the two downsides. But the upsides are very large, especially for agile development, especially when you're working, you're doing these iterations every 2 weeks and you're talking to these customers and they come up with a new idea. You want to be flexible, so we're encouraging you to do that. Okay, go ahead and talk about cloud computing. Cloud computing, which you hear about all the time, and then some of these fallacies and pitfalls here. As I said, Armando and I think of cloud computing as one of the big events here in software as a service. So what do you need to do software as a service? You need 3 things. You need to be able to communicate, right? You have this client that's got a portion of your application, that's what the user's using, and they're reaching out over the internet and the cloud. And so, that's basically wireless communication internet. You need scalability. Because there's only one copy of software as a service, it's running basically in one place, you have to be able to deal with millions of examples of people if you're lucky. Or just it's a busy time of year. If you're doing a photo service, right after Halloween's your big day. If you're eBay, you're selling things, it's right before Christmas is your big day. It depends on the service, but there'll be a crush of people using it. You got to handle that. If you don't handle that, people will get mad and they'll stop using your service. And the final thing, it's got to work, right? That's, if one good thing about everybody having their own copy of the software, even if it doesn't work for some people, probably it works for most people. If there's only running one place, it's got to be dependable. It's got to be available every day, 24 hours, 24/7. And we'll talk about some dependability things later in the course. Okay, so when the first internet services got built, they said, well, it's got to be dependable, it's got to be scalable. We'll just use the really best hardware there exists. Buy mainframes from IBM, that's gold-plated, it's the least likely hardware to fail. So what the problem with that was, and that was the original strategies, was that it was pretty expensive, and a lot of these internet services are free or cheap, or they're going to be based on advertising, so you want to bring the cost down. And they still failed sometimes, even though they failed less than cheap hardware. And they didn't scale all that well. You bought a big machine from IBM. What happens when you exceeded that capacity? Well, then you're going to have to buy another one, and it's going to deal with distributed computing. So what became popular is what's known as clusters, and this actually dates back to a project at Berkeley called the Network of Workstations project, where rather than building a really big computer, a big expensive computer, we'll build it out of little ones, and workstations, or you think of it as PCs, and we put them together using standard Ethernet switches. And so we use commodity computers, which are much cheaper, and commodity switches, and we can build things out of, at Berkeley, we built hundreds of computers to act together as one, and then this kept growing over time. It's more scalable than conventional servers because it's a distributed network. Each piece is independent. Each has an independent operating system, and you plug them together with an Ethernet. It's tremendously cheaper than the gold-plated one. Luis Barroso and Urs Hölzel, 2 of the lead engineers at Google, in their book on warehouse-scale computing, they estimate it's about a factor of 20. So if you buy DRAM at IBM versus DRAM for a PC, if you buy processors from IBM versus processors for your PC, you're paying factors of 20 difference there. So that's huge. To get the dependability, another benefit is if you make it all the same, you can reduce the difficulty of operating. If it's 1,000 copies of exactly the same thing, it's a lot easier to manage, so you don't need as many operators as you might think. The other thing that became popular is virtual machine monitors, so that you could have a layer of software that runs on top of the native operating system that you could control. So you could kill things, distribute things, so VMs help with that. And what do they do about dependability? Well, since it's 20 times cheaper, you can afford to have extra copies. That's basically the idea. So maybe you'd have twice as many processors as you need, or twice as many disks as you need, but they're 1/20th the price, so it was okay. So we will handle in software the failures that are going to happen. Even in IBM machines, mainframes are going to happen sometimes. They're going to happen a lot more in PCs, but so what? We've got enough dependability in the software that'll handle it. So that is the argument. That's the argument for clusters. Now, what happened is clusters went from, like, we had a 100 cluster node, the Now project at Berkeley, and then there was a startup project, which was one of the early search engines called Economies. Then they went to 1,000 servers, 1,000 PCs. What's happened over time is all these internet services got more and more popular, and so they had to make bigger and bigger clusters. Today, they have 100,000 servers to be able to serve these big applications. And they discovered some things. Oops. What they discovered is the bigger they made these things, the more economies of scale they got. So when you had 100,000 servers and you go to Dell, you say, I'd like to buy 100,000 servers, you get their attention, right? And you can negotiate them a price that's much better when you buy that many. They could, it was more economical to house 100,000 computers. You could build a whole warehouse just for yourself, perfectly designed with really good cooling. When you bought internet bandwidth, if you go there and buy enough internet bandwidth for 100,000 servers, it's much cheaper in volume than it is to buy one server at a time. So they've noticed there are these large factors, and it's been estimated, factor of 5 or so cheaper to build the data center by the volume. The other thing that they notice in terms of the cost is when you have smaller data centers and they're distributed all around, they're not all that well utilized, typically 10 or 20%. If instead of these kind of per company data centers, if you could consolidate 100 companies together in one giant facility, the utilization would go way up, because when some people are not doing any work, other people would be. So they get another cost benefit of increasing the utilization of the hardware that they built. And so what somebody realized, and it was actually the same Jeff Bezos, the guy, the CEO of Amazon, what he said in 2007 or 2006, well, if you guys think our warehouse scale computer is so good, you should be able to sell it. You should be able to go to the market and rent it if it's that great. And so in 2006 or 2007, they started offering EC2, Elastic Computing 2, where they would sell time on their machines to people. Now, what they did originally, what the engineer made an argument is, look, we have this big crush at Christmas. We build out our thing to sell things at Christmas, but for 11 months of the year, it's underutilized. So why don't we make money from that? And there's an article you can find on the web, the engineer giving a talk in South Africa, of all places, about this proposal as we can make money from the idle time. So that got Amazon into it, and it became very popular. One of the reasons it became popular, they made it very easy. There was no contracts to sign. All you needed is a credit card, and they would let you have machines. Question? So the question was, does that mean EC2 is not available at Christmas? When they got started, it was to use spare cycles. It got so popular that for many years now, it's been an independent service. So I think Amazon doesn't depend, EC2 users do not use the Amazon infrastructure. Whether the Amazon infrastructure does use some of the cloud computing on EC2, I'm not sure, but they're completely separate now. It became so popular that they have an organization, Amazon Web Services, that's all about anticipating the need that people want and building out these warehouses and giving you this illusion that you have infinite capability. All right, and this became known as utility computing or cloud computing. This is an idea that's been around for, as you'll see in the book, 50 years in computer science. Well, maybe computing should just be a utility like electricity or gas rather than us owning our own. And you can, at pennies per hour, you can get computing, storage, and communication, the 3 pieces. And one of the things that's striking to me is that there's no premium of scale. Usually in computer science, if you want a really big one, you have to pay extra. So a supercomputer or a mainframe costs a lot more per computron than a PC. But great, One computer at 1,000 hours is exactly the same cost as 1,000 computers at 1 hour. So you can, at your fingertips, have huge numbers of machines, and all you need is a credit card. And your impression is it's infinitely scalable, and it's their job to provide the machines to give you that impression, but not to overbuy it. So as many as you can afford. Amazon Web Services is clearly the leading example. Google App Engine and Microsoft Azure they tried their own models that apparently didn't work as well. So now both Google App Engine and Microsoft Azure have a similar model of Amazon of running virtual machines and providing that. To give you an idea of what the costs are like, this is what the costs are today. So the one that you hear about, the standard small here, is 8 cents an hour. And you get, it's the smallest machine. It's got a 32-bit address, but you get 160 gigabytes of disk, 1.7 gigabytes of memory. And then they have these virtual units of compute units that they made up. It kind of matches an Intel processor in 2006 or 2007. And that's what they call compute units, or virtual cores. And it goes all the way up this $2.40 an hour one, which they claim it's 88 times as fast as the cheap one. What else it has? It has 1.7 terabytes of disk space. It's a 64-bit address space and has 60 gigabytes of memory. So over time, there's 10 examples here. Over time, they keep adding ones, and they only adjust the price a little bit. I think it started off at 10 cents an hour for that standard small size in 2007, and here it is, 5 years later, and they've only dropped the price 20%. So at the time they came out, their competitors were convinced that Amazon was losing money hand over fist. Now you hear people talking about how incredibly profitable Amazon Web Services be, but from the perspective of users, wow, credit card, I could get 1,000 machines for whatever that is, $800 an hour. That seems like a pretty great thing, and it became quite popular.